Today we are going to discuss about data. Okay. What is data? When we are doing the data mining or data analysis, we need to understand the data structure that we are going to use. Based on the definition, we can have structured data and unstructured data. So let's see what is structured data. Structured data, often numbers or labels, stored in a structured framework of columns and rows. So if you look at Excel or any spreadsheet, okay, so those kind of things are related with the structured data. You have rows, you have columns. What is unstructured data? Unstructured data is text-heavy information that's not organized in a clearly defined framework or model. Let's say you read news, okay, in the newspaper. So you can see a lot of text. So those kind of data are unstructured. Or maybe if you are using your social media, you can see online reviews. Customers or people on the internet, they can give reviews and it is based on text. There is no structure on this text. But there can be some data in between the structure and unstructured. We call it semi-unstructured, or maybe sometimes some books mention semi-structured. It is loosely organized into categories using meta tags. For example, if you see your email is semi-structured or semi-unstructured. Why? In your email, you can see from, you can see to, you can see subject. So those are in the structure. You need to put those three in your email. But we also have contents. So the email contents can be anything. So the email contents is unstructured. But the from, to, and subjects, they are structured. So it is the semi-unstructured or semi-structured. What we are going to analyze in this semester is more about the structured data. The structured data means, we have spreadsheet or we have like CSV file. I'm not sure if you're familiar with the CSV file. CSV is comma separated values. So we will also use this file during our class. And you can also use the database. So those kind of data source are the structured data. And it is visible. We can see it. However, many of these data, like the semi-structured or the unstructured data, they are hidden. The invoice or purchase orders, when you make contracts or when you write some mortgage apps, okay, and let's say the unstructured emails, maybe emails can be unstructured or can be in the semi-structured, okay. Images, video, instant messaging voice, okay. So those are not in the good structure, and if you want to analyze it, you need to make it as a structured data. Okay. That's why I think last time I mentioned about John Chori. So pre-processing, it is necessary. Okay. So when you do this data mining class, I think it's better to focus only on the structured data. If your data is in the semi-structure or R structure, it means you need to do more. Okay. Types of data sets. There can be a lot of types of data sets that you will see later. The first data type is, the first data set is a kind of record. Sometimes people mention as relational record, document data, transactional data. For example, this one is a record data. We have 3 rows and we have 1, 2, 3, 4. We have 5 columns. Okay, so this is a kind of record data. We can also have the graph and network data. WWW. Have you ever heard? This is World Wide Web. Okay, good. Thank you. So we have our internet. Okay. Usually it started with WWW. It is the World Wide Web and it is connected. Google can connect to other websites. So we can make it as a graph or we can make it as a network. Social network data, information network data. So all those data can be represented in a graph. There's another kind of data, we call it order data. The order data, it means we have order or we have the sequence. Which one is the first and which one is the next. Video data. We have the starting point. We have the middle point. We have the ending of the video. Temporal data. We call temporal. Usually it is about time. Okay. So every temporal data, we have timestamp or time. For example, what is the time you arrive in the school? What is the time when you enter the school, enter the gate of the school? There will be a time. So we call those kind of time is temporal data. We can also have sequential data. Yeah, sequential data. Yeah, we have the first, and what is the second? What is the third? What is the fourth? Genetic sequence data. So this is an example of the genetic sequence, like DNA. Yeah, in our body we have DNA, and there will be a kind of sequence. Another kind of data is the spatial, image, and multimedia. Spatial data. Have you heard about spatial? It is something related with the Earth, geography. So let's say we have the latitude and longitude. Or if you have the coordinate X and Y, okay, we can put it as also a spatial. Image data, multimedia data. So those kind of data are some types of the data sets. And Yeah, we can say the spatial data, we can have the image data, we can have the video data. And I think we will focus only on this record. Okay. Let's say if you want to analyze those other data, yeah, you can analyze those data, but later on you need to convert it into the record data. So we need to understand that the data, it contains objects. We call it data objects. So data sets are made up of data objects. And data object represent an entity. Let's say if it is sales database, then it might be related to customers, store items, sales, and etc. Because there will be customer entity. There will be sales entity. Or if it is related to the medical, it can be related to patients. It can be related to the treatments. Or if it is the university database, so we can have the student data. We can have professor data. We have courses data. In the literatures, people can say data rows. But in other books, they can mention it as record or tuple or instance or data object or sample. So they are the same word. Okay. So I also put here samples or examples, instances, data points, objects, tuples. So they are the same words. They represent the same thing. For example, here, the person number 1. Okay, this is, we can say here case ID and gender male. So I guess this is the data about person. And the person age is 22 and he has a high school degree and he lives in Arizona. So this is person number 1. What about person number 2? Okay, this is the person number 2. And this is the person number 3. So in this data, we have 3 persons. Because we have 3 rows, or we have 3 records, or we have 3 tuple, or we can say we have 3 instances, or we can say 3 objects, or we can say 3 samples. So they have the same words. Attributes. Every data objects described with the attributes. We can call attributes as dimensions. We can call as features and variables, or sometimes we call it as data field. Sometimes we call it column. So those are the same keywords. A column, attribute, field, variable, dimension, features. So those are the same words. And it represents a characteristic or feature of a data object. So if the person number 1, the case ID is 1, maybe this is the ID, student ID or something, and then his gender is male, his age is 22, and his degree is high school, and he lives in Arizona. So those are something that explain about this person. And if we have another person, it explains what is the properties of that person. So let's see. In this example, this is one of the very popular data set. We call it Iris dataset. You can take a look on this link. It is a publicly available data set. Iris is a flower name, and it is a kind of experiment done by Ronald Visser. He is a statistician and biologist. So some people mention it as the Fisher's iris dataset because the person who tried to get the dataset is the Ronald Fisher. And in the first experiment, he wants to use the linear discriminant analysis at a time. But people use this dataset as the data mining experiment too. So we can see there are three kinds of flowers: the Iris setosa, Iris versicolor, and the Iris virginica. And in every flower, they have a very specific properties. We call it petal, which is the small properties of the flower, and we call it sepal, which is the bigger properties of that flower. And for every properties, for the sepal and the petal, we can measure. We can measure the length. And we can measure the width. So we have sepal width and we have sepal length. And also in the petal, we can also have the sepal length, and we can also have the petal width. So this guy tried to measure for every flower. If the flower is Iris setosa, he measured for every sepal length, sepal width, petal length, and petal width. And let's go to orange. So this is the first page of orange. And you can start from the widget. Here we call it as widget. There's a file. In the file widget, you can open, and it will show you what kind of source file that you want to use. If you want to open this, you can select some other files, but for now, let's just use the file in orange. So in orange, we have several files. Here, I would like to use the iris.tab. And you can see the information here. It mentioned that it is iris flower dataset, and it is a classical dataset with 150 instances. What does it mean? We have 150 rows. Okay, thank you. So there are 150 data. There are 150 examples. There are 150 instances in this data. And we have 4 features. Features are the columns. Okay. Why we have 4? Okay. We have 1, 2, 3, 4. And actually we have 5. So later on we will learn more why we call this is 4 features. Although we have the 5th, this is iris. So in the role, you can click here. You can select whether the role is feature or target or meta or skip. Okay. So the feature represent the characteristics of the flower. So the target represents something that will determine. So I have the sepal length, I have the sepal width, I have the petal length, I have the petal width. And what does it represent? Because I know that it represents the flower, so this will be the target. I will explain more about this target. Okay. And you can see the target contains of iris setosa, versicolor, and virginica. You can go to this and you can click on the line and you can create another widget. So after you open the file, you can select another widget. For example, I will use data table. Then you will see a kind of table like this one. There are 150 instances, and for every instance, it represents one flower. This is the first flower, it is iris setosa, and the sepal length is 5.1, maybe it is in centimeter. The sepal width is 3.5 centimeter. The petal length is 1.4 centimeter, and the petal width is 0.2 centimeter. And this is the second flower. This is the third flower, fourth, fifth, sixth, and so on. We have 150 data. Okay, so we already know about the instance and the features or columns. Next, we need to understand that the data have several kinds of data. There are two attribute types. So basically, there are two attribute types, categorical and continuous. Okay, categorical. Later, we can split into three, and then continuous. We can split into two. Okay. So we will learn those things today. The first is the categorical data. Categorical attributes or categorical variables. It takes on a small set of possible values. Okay. The keyword is small. So if it is too big, usually they will not consider as categorical. Usually they will consider it as text. Typically, it is called as qualitative, or sometimes called as discrete or qualitative variables. For example, gender. We have male, female. Religion. Here we have Christian, Buddhism, Buddhist, Islam, and etc. Method of treatment. Outpatient, inpatient. Type of teaching approach. We can do online, we can do offline, or blended learning. Marital status. We have single, married, and divorce, and etc. Size. We have small, medium, large. Native language. English, Korean, Indonesian, and so on. Job. Teacher, professor, housewife, and etc. So those information can be sorted into categories. So there are some categories. Some types of categorical attributes are ordinal, nominal, and binary. Let's see one by one. Ordinal as the categorical attributes. The word ordinal, it is a categorical attribute with some intrinsic order. Order means sequence, okay, or in Korean is sunso. We have which one is the biggest, which one is the smallest, or we can have the level. Okay? For example, in the agreement, we have strongly disagree, neutral, agree, strongly agree. Usually in the Korean, you have like questionnaire. Okay? 매우 만족, 만족, 불만족, 매우 불만족. So something like that. So it is also an order, ordinal. Rating. We have excellent, good, fair, poor. Okay? Maybe when you are using some kind of application, you need to make assessment, rating assessment, and you can press number 1, 2, 3, 4, 5. So those things also a kind of ordinal data. Frequency. Always, often, sometimes, never. And any other scale, maybe you can have the numbers from 1 until 5, or you can have number 1 until 10 based on the scale. Okay. So if there is an order, we call it, this is ordinal data or ordinal categorical attributes. Nominal. Nominal is a categorical attribute without an intrinsic order. So there is no level, there is no sequence. For example, city in Korea. We have Seoul, Busan, Daegu, Daejeon, and etc. But maybe you will ask, Professor, Seoul is the capital of Korea. Can we say this is the first? Yeah, you know. You know the Seoul is the capital, but computer, they didn't know. Okay? They will consider it as the same. Sex, male and female, is also same. There is no difference. Nationality is also the same. American, Mexican, French, Korean. We have no order. Favorite pet, dog, cat, fish, snake, and etc. Okay? There is no significant order. Blood type, A, B, O, A, B. There is no sequence. So they are in the same level. Those kind of data, we call it nominal. The other data type in the categorical attributes, we call it binary. Sometimes they call as dichotomous. Maybe this, if you have difficulties to mention this dichotomous, yeah, you can just say binary. Dichotomous or binary attributes, it is a categorical attribute with only 2 levels of categories. Okay. Only 2. Often represents the answer to a yes-no question. We have 2 kinds of binary. The first is symmetric binary, and the other is asymmetric binary. The symmetric binary means both outcomes equally important. For example, gender. There is no different importance between male and female. Okay. In asymmetric binary, outcomes not equally important. Usually it happens in the medical test. Let's say in this case, in the pandemic era, when you are tested positive, it is important. You need to go quarantine or you need to go to hospital. Okay? If you are tested negative, you can be free. So that's the asymmetric binary. And if you are tested positive, you will be calculated in the statistics. So today there are, I don't know, 30,000 tested positive. So yeah, we have the numbers because positive is more important than the negative. Usually we call it the importance as number 1, and the not important is 0. So when you are tested positive, you will be assigned as 1. And if you are negative, you will be assigned as 0. Yeah, the example is like sex, we have male and female, so it is symmetric. Attend party, yes or no. Join conference, yes or no. The medical test, we have positive or negative. Okay. So those things are the examples. We can have another data types. We call it continuous or numerical attributes. Numerical or continuous, it is always numeric or quantitative. And it can be any number, it can be positive, it can be negative. So those are the examples. We have height. We have, for example, height in centimeter. So those are numbers. We have weight in kilogram. So those are the numbers. We have income. Let's say how many US dollar per hour. So those are the numbers. Speed, kilometer per hour. Those also numbers. Temperature in Celsius. Yeah, those are numbers. Age in years. Those are numbers. Income tax in the percent. Those are numbers. Blood pressure. We have the metric for the blood pressure. Yeah. So there are two types of continuous attributes, interval and ratio. The interval continuous attributes, it is data like ordinal. So similar to ordinal, ordinal, we have the order. Okay. Except we can say the intervals between each value are equally split. So it is measured on a scale of equal size units, and the values have order. For example, 0 degrees Celsius is different with 20 degrees Celsius. So we have order. So 0 is smaller than 20. Calendar. We have also the order. Yesterday, today, tomorrow. Okay. And there will be no true 0 point. It means, let's say in the Celsius, we have no true 0 point, even though we have 0 Celsius, but we still have minus 20. We can have positive 30 degree. Okay. So the 0 is nothing, is not that important because it is just a number. So some examples mention that the difference between 20 and 21 degrees Celsius, because we have only difference 1 Celsius, is the same with the difference between 34 and 35 degrees Celsius. So there's one difference and the differences are the same. Ratio data. Ratio data is interval data, so it's the same, with a natural 0 point. So we need to understand that the data has inherent 0 point. For example, we can also say that this ratio data We can speak of value as being an order of magnitude larger than the unit of measurement. So 10K is twice as high as 5K. Do you know K? Kelvin. Okay, that's right. So this is a heat measurement. Okay, K means the Kelvin. I guess you learned before the heat measurement. We have Celsius to indicate the temperature. Okay. We have Fahrenheit. We can also use Kelvin as the measurement. So in this measurement, there will be a kind of measure to see the ratio that 10 is twice as much as 5. And the important thing is the 0 point. In Kelvin, the degree in Kelvin starts with 0. For example, age, we know, right? Age, human age, start with 0. Length. When we want to measure the length of this table, it starts with 0. Okay? There is no negative value. So we call this is the ratio. So I would like to explain another data set. It's called Titanic Dataset. Have you heard about Titanic? So this is a big tragedy in many years ago. It is a big vessel and there was an accident. And they try to save the passengers' data. So let's go to Orange. In Orange, there is a Titanic data. You can go to File. And you can select this file. There are some other data set, but let's see this Titanic.tab. Okay. The second is Titanic.tab. And when you click this Titanic.tab, you will see the information. It is the Titanic dataset. The data from the real Titanic passengers and their survival. And you can see there are 2,201 instances. And we have 3 features. And the classification is categorical class with 2 values. Usually, this kind of data set, they will not include the details in Orange, but they have the details in some kind of internet or in the public. Okay? So I give this description. Whenever you have a data set, you need to find this description. You need to understand what is the meaning of that column. Because we are not the expert of all data sets. So we need to see what is the meaning of that column. Survive means whether the passenger survived or not. So if you look at the information survive, we have 2 values, no and yes. And then status. Is this the cabin status where the passenger stayed? You can see the status. We have crew, first, second, and third. So it means the passengers stay in the first class or the second class or in the third class, or whether he or she is a crew. And then age of the passengers. The age represent 2 kind of values, adult and child. So it does not represent a real number, but it represents with the only adult and child. And sex, we have female and male. At the first part, you need to check what is the data type. In this case, what is the data type? Binary. Maybe let's say from the big picture, we have two kind of data set. We have two kind of data types, categorical and continuous. Okay? Whether the data is in the category or it is in the numeric. It is in the category. Status. It is also categorical. Age. It is also categorical. And sex is also categorical. Maybe you can say sex is binary. Yes, okay. Or you want to say the survive is binary because it has yes or no. That's also fine. Okay. If you understand this data type, then it will be easier for you to do more analysis. Okay. So this is the learning check. You know about how many attributes in the data. And yeah, I give you this question so you can review what you already learned, what I explained in this class.